Hi all, this is Mrs. Pettit here with you one more time to walk you through how to find the surface area of cylinders, cones, and spheres. Like a prism, a cylinder has two bases. In this case, the bases are circles in parallel planes. The cylinder also has an altitude, which is the perpendicular distance between the bases. And it also has an axis that connects the centers of the circles. In a right cylinder, the altitude and the axis are the same segment. In an oblique cylinder, the axis connects the centers of the circles, but the altitude is still the perpendicular distance between the bases. To find the lateral surface area of a cylinder, it's very much like finding the lateral surface area of a prism. To find the lateral surface area of a cylinder, you need the perimeter of the base times the height of the cylinder. But in this case, the perimeter has a special name, and that's the circumference. So to find the lateral surface area, you'll multiply the circumference times the height. And to find the total surface area, you'll add the lateral surface area to the area of two bases, where capital B is the area of one base. So let's try a couple of examples. If I want to find the lateral surface area and the total surface area of the right cylinder shown, I'll start with the formulas for lateral surface area first. So the lateral surface area I find by taking the circumference times the height. And I find the circumference of a circle by multiplying 2 pi r. And then to find the lateral surface area, multiply by the height. I know the radius is 2.865, and the height is the distance between the bases, so in this case, 12 inches. And since I can't get that to come out to be in exact form, I'm going to use the pi button on the calculator and get an approximate value for the lateral surface area of 216.02 inches squared. To find the area of one base for a circle, that formula is pi r squared. And again, I know the radius is 2.865. And again, because I can't get that in exact form, I'll use the pi button on the calculator and find that the area of one base is approximately 25.79 inches squared. To find the total surface area, I'll take the lateral surface area of 216.02 and add that to 2 of the bases, which are each 25.79. So the approximate total surface area for the right cylinder shown is 267.6 inches squared. To find the height of a right cylinder, if the diameter is 10 centimeters and the total surface area is 110 pi, I'll just start with the total surface area formula, which is the lateral surface area plus the area of two bases. And again, lateral surface area I can find by taking the circumference, which is 2 pi r, times the height, and the area of one base is pi r squared. I can start to plug in what I know and then work my way back to find the height of the cylinder. If the diameter is 10 centimeters, I know that the radius is 5 centimeters. So I'll just start plugging in here. I know that the total surface area is 110 pi. If the radius is 5, then I can plug that in for r in both cases here. And then I start to work my way backwards. I see pi in every term, so that can cancel out. So I'll have 110 equals 10 times the height plus 2 times 5 squared, and 5 squared is 25, so times 2 is 50. When I subtract 50 from both sides, I get 60 is equal to 10 times the height. And when I divide both sides by 10, I find that the height is 6 centimeters. Now let's take a look at how to find the total surface area of a cone, which is very similar to finding the total surface area of a pyramid. Like a pyramid, a cone has one single base, and like a cylinder, that base is a circle. The axis is the segment that connects the center of the circle to the vertex. And the altitude of the cone is perpendicular to the base and connects the vertex to the base. So in this case, the axis and the altitude will be the same segment. And we also need to know the slant height, which we called L. And here, that's the distance from the vertex to the circumference of the base. So like the lateral surface area of a pyramid, we need 1/2 the perimeter of the base times the slant height. But again, the perimeter of a base for a cone is the circumference times the slant height. So we need 1/2. We find the circumference by taking 2 pi r and multiplying by the slant height. And you'll notice that the 1/2 and the 2 cancel, so the lateral surface area can be found by taking pi times the radius times the slant height. And the total surface area of a cone is the lateral surface area plus the area of one base. So again, that capital B is the area of one base. Let's try a couple of examples. In the first case, it's asking us to find the lateral surface area and the total surface area of the right circular cone shown. So the lateral surface area we can find by taking 1/2 the circumference of the base times the slant height, or pi times the radius times the slant height. So the first thing we're going to need in this problem is the slant height. And if we take a quick look, we'll notice that we have a 3, 4, 5 triangle times 5, which will give us our slant height of 25 centimeters. If you didn't see that, you'll just plug it into the Pythagorean theorem and you'll find the slant height is 25 centimeters. And then we can just go back and start plugging into our formula. I have pi times the radius of the base, which is 15, times the slant height, which is 25. And in exact form, that will give us 375 pi centimeters squared as our lateral surface area. To find the total surface area, we'll also need the area of one base, which I can find by taking pi r squared. Again, the radius of the base is 15. 15 squared is 225. So 225 pi centimeters squared is the exact area of the base. And the total surface area is found by adding the lateral surface area to the area of one base. And when I add those together, I find the exact total surface area to be 600 pi centimeters squared. In the next example, we know that the total surface area of a right circular cone is 55 pi, and the slant height is 6. We want to find the radius. So again, we'll just start with the formula for total surface area, which is the lateral surface area plus the area of one base. The lateral surface area is pi times the radius times the slant height, and the area of one base is pi r squared. And I can just start plugging in what I know. I know the total surface area is 55 pi. The radius is what we're looking for, and the slant height is 6. And again, the radius is what we're looking for. So when I start to solve this equation, I can see that there's pi in every term, so those get eliminated. And when I simplify both sides, I see that I'm going to have a quadratic. And the first step in solving a quadratic is to get it set equal to 0. So if I subtract 55 from both sides, I'll have r squared plus 6r minus 55 equals 0. And when I break that into its factors, I'll have r plus 11 and r minus 5 equals 0, which leaves me with the options of the radius either being negative 11 or positive 5. And since we know that a distance can't be negative, the radius of the right circular cone must be 5 units. Now let's talk about how to find the total surface area of a sphere. First, we need a couple new definitions, and one is, what is a sphere? And that's a figure in space that is a set of all points that are a given distance from the center. So the figure at the right is a sphere. And we also need to understand what a great circle of a sphere is. And that's the intersection of a plane and a sphere when the plane passes through the center of the sphere. So this would be the great circle. The other thing we need to understand is that there will only be total surface area, and it will be found by using the formula 4 pi r squared. There's no lateral surface area because there are no edges to create the distinction between the lateral surface area and the area of the bases. So there's only total surface area, and again, found by the formula 4 pi r squared. So in the first example here, if I want to find the total surface area, I just use the formula 4 pi r squared. And if the diameter equals 12, then I know the radius equals 6. And I can just plug that in here to my formula. 6 squared is 36, times 4 is 144. So the exact total surface area for a sphere with a diameter of 12 is 144 pi units squared. To go through one more quick example here, we want to find the radius of a sphere whose surface area is 300 pi. So again, we'll just start with our formula. Total surface area is equal to 4 pi r squared. The total surface area is 300 pi. And when I start to solve, I notice there's a pi on both sides, so they get eliminated. When I divide both sides by 4, I'll get 75 is equal to r squared. And when I take the square root of both sides, I'll get the radius is equal to the square root of 75, Well, technically this positive or negative square root of 75, but we know that the radius can't be negative. So we'll be focused on the positive square root of 75, which I can break down into rad 25 and rad 3. So the radius in exact form will be 5 rad 3 units. Let's look at one last circular solid. It's known as a frustum. We're going to think of it as a big cone minus the little cone, where we can use right triangles to find unknown dimensions. So we're going to think of this frustum as a big cone minus a small cone. Where we're going to use similar triangles to find the dimensions that we need. Let's start by marking up the diagram with what we know. We know the slant height of the frustum is 13 inches. The radius of the bottom is 15 inches. And the radius of the top of the frustum is 10 inches. The first thing we're going to need if we want to find the lateral surface area and the total surface area of the frustum is the slant height of the smaller cone so that we can find the slant height of the larger cone. So we can use our similar triangles and we can say x over 10 is equal to x plus 13 over 15. And when I cross multiply, I get 15x is equal to 10x plus 130. Subtracting 10x from both sides, you're left with 5x equals 130. And dividing both sides by 5 gives x equal to 26. So the slant height of the smaller cone is 26, and the slant height of the larger cone is 39. So if I want to find the lateral surface area of the bigger cone, I can find that using pi RL and pi. The radius of the bigger cone is 15, and the slant height of the bigger cone is 39. So the exact lateral surface area of the bigger cone is 585 pi. I'm also going to need the lateral surface area of the smaller cone if I want to find the total surface area of the frustum. And again, the formula is pi RL. In this case, the radius is 10 and the slant height is 26. So the exact surface area of the smaller cone is 260 pi. And the lateral surface area of the frustum is the bigger cone minus the smaller cone. So the lateral surface area of the frustum will be 325 pi inches squared. If I want to find the total surface area of the frustum, I'll need the area of the base of the bottom, so we'll say of the bigger cone. So formula is pi r squared. So I'll have pi times 15 squared The area of the base of the bigger cone is 225 pi. I'll need the base of the smaller cone because that's the top of the frustum. So again, pi r squared, where this time the radius is 10 for an area of 100 pi. And if I want the total surface area, I'll take the lateral surface area of the frustum, which I already found, and add one big base and one small base. So when I plug that all in, I have 325 pi for the lateral surface area, 225 pi for the area of the big base, and 100 pi for the area of the smaller top of the frustum. And when I add all that together, I get 650 pi inches squared as the total surface area of the frustum. There's one more review problem at the bottom of this packet, and it's to find the total surface area of the right prism. Remember that the faces of a prism are parallelograms, and the bases are what there are two of. So remember, it may not necessarily be what the prism is sitting on. The bases are what there are two of, and the faces are parallelograms. I'm going to let you give this one a shot. I'm going to tell you that the total surface area is 43,600 inches squared. Give it a go and see if you can get that.